Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Twins Before Birth by Will Power. And I guess we can sort of see them. We have one twin whose head is looking this way. This is his sort of legs and his arms. And this is another twin. He's got a larger head though here. And this is his arms and this is his legs. Anyways, let's get to the rules. We have normal Sudoku rules apply, which means in every cell in this grid, place a single digit such that there from 1 through 9, such that there are no repeats in any row, column, or designated 9-cell region, which is the box here. We have anti-king rule, where cells a chess kings move apart cannot be the same number. So, for example, if this were, say, a 5, in addition to having no repeats in the same row or column, you cannot have a repeat in a king's move away from any cell. So this normally could be a 5, and these two could also normally be 5s. But in this puzzle, because of the anti-king rule, these can no longer be 5s too. So you could not have a 5 in these 9s or 8 cells surrounding the 5. And that's anti-king rule. We have thermometers, where numbers on a thermometer increase from the bulb to the tip. So basically, it will be always increasing from the bulb to the tip here. So we could have, as an example, say 1, 2, 4, 5, and 7. And that would work for this part of the thermometer. What you could not have is something like, say, 1, 4, 4, 5, 7, because even though it's increasing from here to here and from all of these, it's not increasing from this cell to that cell. And that is specifically not how this thermometer works. There are other thermometers where you can have slow thermometers where it just doesn't have to be decreasing, but on this thermometer, it must be continuously increasing from the bulb end to the tip. And that's how thermometers work. We have arrows, where numbers on arrows sum to the number in the arrow's pill. And the pill is read from the top to the bottom. So that means the numbers on the arrows, so that would be this case, sum to the number in the arrow's pill. And it's read from top to bottom, which means the top is the tens digit and the bottom is the ones digit. So if this were 2 and 4, that would be 24. If this was 1 and 5, that would be 15. It would not be 51. And both this arrow here sums to this number, and this arrow here sums to this number. So that's one thing you have to remember. It's not the sum of all the digits on the arrows. It's basically the arrows independently. And this digit is shared by both arrows, essentially. And that's how arrows work. We also have Renban lines, where numbers on purple lines are each a set of non-repeating consecutive numbers in any order. So you could have along this Renban line something like 4, 6, 5, 7, and 8, and that would be valid because these are a set of consecutive numbers. That means there's no hole in between any of the neighboring digits, right? But it can be in any order, and you do not have repeats. So you cannot have something like 4, 6, 5, 7, 5, because that's repeated along this Renban. So this would not be valid here. And that's an example of how Renbans work. And finally, we have killer cages, where numbers in cages sum to the number in the top left corner of the cage. So these two, actually, we have another rule set. Sorry, I got fooled by the formatting here. But killer cages, These two digits must sum to 8, these three must sum to 17, these three must sum to 20, etc., etc. So for example, if this were a 6, you would know this would have to be with a 2 because these two digits must add up to 8. And that's an example of how killer cages work. And then finally, we have crop key dots, or specifically white crop key dots, where numbers with a white dot between them are consecutive, and not all possible dots are shown. So for example, if this were a 6, this would have to be a 5 or a 7 to make sure that these two digits are consecutive. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, so what I like doing, particularly with long thermometers, is going from the bulb to the tip, looking at what the minimum value is, and then going back from the tip to the bulb, looking what the maximum values could be. So, and then restricting those cells based off of the minimum and maximum values. So we take a look. This is 1 at minimum because that's the lowest digit in Sudoku. This is 2 because it's greater than that digit. These both have to be 3 at minimum. These both have to be 4 at minimum because they're greater than these digits. And these are both 5 at minimum. Then we have 6, 7, and 8. So this has to be 8 or 9 here. This is 9 at max. This is less than that. So this is 8 at max. This is less than that. So this is 7 at max, 6, 5, 4, 3, and 2. So this is the restriction for these cells. This is 9 at max, 8 at max, 7 at max. But if this is 7 and 8, that would eliminate all possibilities for that cell. So this cannot be 7 at max. This has to be, so if we tried this being 7 and this being 6, because these are specifically consecutive. So if we had 7 at max and 6, this would force this to be 6, but then this cell would not have a possibility. So this can't be 7 either. So what if we tried 6 at max? Well, then that works because 6 and 5 works, 5 and 4 works, or 3 and 4 works. So this is 4, 5, or 6 because we don't have specifically in this cage. Actually, we do have a problem here. These two are consecutive. This is only consecutive with 7, 8, or 9. In this central box, then, we have a 7, 8, 9 triplet, which eliminates 7, 8, and 9 in the rest of the box. This can't be 7, therefore this is 6, which makes this 5, which makes that 4, 3, 2, and 1 to be less than each of these digits. This 6 eliminates 6 here, and this, so this can't be 5 because this is less than that and it's consecutive. This 3 eliminates 3 here, so this must be 4, which makes this a 5. Oh, this is 5 through 9, but it can't be 5 anymore because it must be greater than 5. So we know this is 5, this is 4. The rest of the digits in this central box are 1, 2, and 3. And this can't be 3, and it can't be 2, so this must be 1, which means these can't be 1. This becomes a 2, 3 pair here. Two digits adding up to 8 cannot have a 1 here. So it must at least be 2 and 6. Well, it can't be 2 and 6 because the 2 and 6 here eliminates 2 and 6 in this specific cell. So this can't be 2 and 6 adding up together. So this must be 3 and 5. So this is a 3, 5 pair here. These 4 digits add up to this pill. What is a tens digit of this pill? This could be at most 6, 9 plus 8, 9. That would be 15 plus 17, which is 32. But we already have a 3, 5 pair in this box, so it can never be 30-something. You can't have a 1 in rows 5 and 6, so this can't be a teen digit, like a 18 or 19 or something like that, or 13, etc. So this must be 2 here. It must be 20-something, and we're not sure which. Cannot be 1, 2, 3. Could be 4, no 5, no 6, 7, 8, and 9. So those are the possibilities. We do know, okay, these add up to 21. These add up to 17. That means these 3 digits must add up to what? 45, which is the total of the digits 1 through 9. Subtract out 21, that's 24. 24 minus 17 is 7. So we have 3 digits here adding up to 7. Well, it could only be 1, 2, and 4 as a set, which adds up to 7, because those are the only 3 unique digits that ever add up to 7 for normal Sudoku. This can't be 1 or 4, so it must be 2. This can't be 4, so it must be 1, which makes this a 4. That means, where is the 3 in row 3? It cannot be here, because 3 with 8 and 9, which is the maximum unique digits you can have, adds up to only 20. So 3 has to be one of these digits. This is 3. The rest of the digits are either 5, 9, or 6, 8 here. Well, this can't be 3 or 5. So this is 6, 8, or 9, right? 3, 5, 9 add up to 17. 3, 6, 8 add up to 17. And those are the only unique digits we have now that can add up to 17 in that row. 3 is one of these two. We're not sure which. 5 cannot be here. On a 5-length Renban, you can have the possibilities of 1, 2, 3, 4, 5, 2, 3, 4, 5, 6, 3, 4, 5, 6, 7, 4, 5, 6, 7, 8, or 5, 6, 7, 8, 9. All of them require 5, so one of these two digits is a 5. You can't have a 2 either on this Renban, so since you can't have a 2 at all on this Renban, you can't have a 1. So 1 has to be one of these two. One of these is an 8 because you can only have 9 and 8 or 8 and 7. But if this is 8, 7, that would eliminate all possibilities for this cell. So this must be an 8 and a 9, which makes this a 7. That means this can't be 27. Also, all of these digits, you can't have a 2, so that leaves only 3, 4, 5, 6, 7, 4, 5, 6, 7, 8, or 5, 6, 7, 8, 9. What are these digits? To add up to 12, and they both have to be on the same Renban, it cannot be 3 and 9, because 3 and 9 to form a 5-set Renban wouldn't work. You have 3, 4, 5, 6, 7, or 9, 8, 7, 6, 5. This could be 4, 8, or it could be 5 or 7. If it's 4 and 8, that's 4, that's 8. If it's 5 and 7, this is 7, that's 5. If it's 4 and 8 here, that requires 5, 6, and 7 to be here. Well, this can't be 5. So it would be 5, 6, and 7 as possibilities if this is 4 and 8. If this is 5, 7, it could be 3 through 7. So 3 cannot be here. 3 cannot be here. If it's 3 through 7, this is 3, 5, 7, and we have 4 and 6. So this would be 4, and that would be 6. If it's 4 and 8, okay, this can't be 4. So that's a problem there. So this can never be 3, 4, 5, 6, 7. If it's 3, this 3 has to be here, cannot be here because of a 2, 3 pair, can't be here because of the 3 here, and this cannot be 3 and 9. That would be 3. This would have to be 5, 7, and 4 would have to be... I guess 4 would be there. No, 4 could be here, and this is 6. Okay, that's valid. Okay. Oh, this can't be 5 because of the 5 in the row. Since this can't be 5, where's the 5 on this Renban? Can't be here because of the 3, 5 pair. Can't be here because of the 5 in the row. So it must be here. So this is 5. This has to be 3, 5, and 9 then, which means this can't be 9. This becomes a 6, 7, 8 triplet. Maybe just, yeah, let's not go that route right now. Well, we already did most of them. Okay, so 3, 6, 7, or this is 5 with a 4, 8. If this is 5, 7, and this is 4, 6, and 8, I guess this could be 6 or 8. This could be 4, 6, 8, and this could be 4, 6, 8. So those are all possibilities. If it's 5, 6, 7, 8, 9, this is 5, 7. We have 6, 8, 9, 6, 8, 9, 6, 8, 9. Okay, so that was not useful. We have 3 digits here adding up to 21. You cannot have a 3, 4, or 5 with it. That eliminates 4, 8, 9, and 5, 7, 9, which leaves 6, 7, 8 as the only possibility. So this is 6, 7, 8. This can't be 6. This can't be 7. That means one of these is a 5. This cannot be 5 because of a 3, 5 pair here. Because we need 5, either 5, 4 or 5, 9 here. And 5 cannot be here because of the 5 in the column. So this is 5, which eliminates 5 from being here. That means this can't be 9 because of the 9 in the column, so this is 4. That means 5, where is 5 on this Ren band? It can only be here. So this is 5 and 7. This 5 eliminates 5 here, so it's 3 and 5. The rest of the digits in row 6 are 4, 8, and 9. The rest of the digits in row 3 are 3 and 6. And this can't be 3, so this must be 6, which makes this a 3. We have 5 and 6 already here. We need a 7, so one of these is a 7. Okay, remaining digits in column 4 are 6, 7, 8, 9, but this can't be 6, 7, or 8 because of the 6, 7, 8 pair in the box, so this, or triplet in the box, so this is 9. This can't be 1 because of the 1 in the column, so this is 2, this is 1. 2 eliminates 2 here, so this is 3 and 2. We have 6, 7, 8 remaining in column 4. This can't be 7 anymore. We cannot have a 7 on the line. We need a 6 on the line, right? It's either 3, 4, 5, 6, 7, 4, 5, 6, 7, 8, or 5, 6, 7, 8, 9, all of which require a 6. So this cannot be 6 because one of these must be a 6. This can no longer be 9 because of the 9 in the row. Okay. Remaining digits in row 1 have to be 1, 4, 7, 8, 9. This can't be 4 or 9. This cannot be 1. And that's all we have right now. Okay, we need a 5 on this Ren band line. 5 cannot be here, 5 cannot be here because of the 5s in the column, so 5 has to be one of these. 5 cannot be here, so this must be a 5. So to add up to 20, we have 5, 6, and 9, or 5, 7, and 8. Well, in column 4, or 6, sorry, we have a 7, 8, 9 triplet, which eliminates 7, 8, 9 the rest of the column. So this must be a 3. 7, 8, 9 is all the consecutive with 6 through 9, and we can't have a 9 here. So that works there. This is 6 or 8, cannot be 7. Since this is 6 or 8, remember we have 6 and 9, or 7 and 8 here. This have to add up to 15 also with this digit. Because these add up to 15, these must add up to 15, because 6, 7, 8, 9 adds up to 30. So with that, where is the 9 actually in... Oh, this could be 6, 8, 9. Apologies. Right. This is 6, 7, or 8. This does add up to 15 with this cell anyways, because these already add up to 15. So it's either 6, 9. This can't be 6 then. It cannot be 8 because it can't be 7 here. So this is an 8, 9, 8. We have an 8, 9, 8, 9 pair in column 5, which eliminates 8 and 9 in the rest of the column. So this is a 6. This can't be 6 here. This digit has to be 9 or 4. And it could be either one to add up to be on a Renban with these digits. Okay. These digits must add up to 20 something. So must these. This has to be 1, 2, 6, 7, 8. It cannot be 9. These digits cannot be 3, 4, or 5. And it can't be 2 because we have a 2 that sees all of this Renban. We also can't be 1 because the 2 can't be on this Renban. So it cannot be 3, 4, 5, 6, 7. It has to be 4, 5, 6, 7, 8, or 5, 6, 7, 8, and 9. So this is 6, 7, 8, or 9 here. It cannot be 6 because of the 6 on the Renban already. Okay. So what are the possibilities here? If this is 1... Okay, say this is 7. Let's say it's 8. That seems like a lot of possibilities. Let's add these up first. This adds up to 15 because they are the digits 1 through 5. So, if this were a 7 or 8, this already adds up to 15. Say this was 7. Say this was not a 1. If this is a 7 at minimum, 1, 2, 3, 4, 5 plus 7 is 22. 22 plus 8 is 30, which is already greater than this digit. So this has to be a 1. So this has to be 1, which means this can't be 1. This can't be 1. This must be 1, 4. This adds up to 15. Plus 1 is 16. Plus 8 must add up to 24. 9 adds up to 25, but that's not allowed because of the 5 in the box. So this must be 8, which forces this to be 9. This is 24. So none of these can be 4. Therefore, these are the digits 5, 6, 7, 8, and 9. 1, 9, and 6 adds up to 16, so it must be with 8. So this is 8 here, which means this can't be 8. This can't be 8. 4 eliminates 4 here. Therefore, all of these digits see this cell, so it cannot be the digits 5 through 9, because then 8 and 9 would be eliminated for this possibility for this cell. So this cannot be 9, this cannot be 9, this is 6, which means this cannot be 6. Apologies. This can't be 6 anymore. So it's either 3, 4, 5, 6, 7, which would be 3, 4, 5, 6, 7, or it's 4, 5, 6, 7, 8, with 4 and 8 being here. Okay, this 8 eliminates 8 here. So here we have 6 or 7. And because of that, it has to be 7, 8 here. If it's not 7, 8 here, the problem is that if we tried to make this 6, 9, this would be 7, but there would be no 8 possible on this Renban. So it would not form a consecutive set. It would be 4, 5, 6, 7, 9. So this has to be 7, 8, which eliminates 7 and 8 from the rest of the box and the row. So this can't be 7. This is 6. This is still 4 or 9. The 7, 8 pair eliminates 7, 8 in the rest of the box. So this is 9. This is 6. What else do we have? We have anti-king, right? So this can't be 9 anymore. Do we have anything else? All 6, 7, 8 see that cell. So this can never be 8. This has to be 4. because they all are kings move away from that cell, and all three of these digits must be 6, 7, or 8 in the row. Therefore, this is 4. This can't be 4. This is 3 or 8 here. The remaining digits in this row 4 are 6, 8, and 9. One of these three digits is an 8, right? So, and this sees this cell from normal Sudoku. These two digits see this cell from anti-king synergy, so this cannot be 8. This has to be 7, which means 7 can't be here or here. What else do we have? Remaining digits in column 7 are 2 and 7. 2 can't be here because of the 2 in the row, so this is 7, which makes this 2. This 7 by anti-king means this can't be 7. This is 8, this is 7. That 8 forces this to be 7 and 8. This 8 eliminates 8 here by anti-king, so this is 6 and 8. This can't be 6 anymore. This can't be, this has to be a 6 here, because that's the only place for it in the box. Rest of row 7 is 1, 2, 7, and 9. This can't be 1 or 2 because of the 2 in the column and the anti-king thing, so this must be 7 or 9. The 7 or 9 pair eliminates 7 and 9 in the rest of the row, so this must be 1 or 2, and this must be 1 or 2. Okay. In row 9, we have 1, 2, 3, and 9 as possibilities. This can't be 1 because of the 1 in the column. This can't be 2 because of the 2 in the column. This can't be 3 because of the 3 in the column. Where is the 5 in row 8? Can't be here because of the 5 in the box. These are all filled out. Can't be here because of the 5 in the column, so this must be a 5. The rest of row 8 is what? 3, 4, 6, and 8. Cannot be 6 in any of these cells because of the 6 in the box, so this must be 6 here. So it's 3, 4, and 8. This has to be 4 and 8 because the 3 can't be here because of the 3 in the column. This is 3, 4, and 8. Well, this 3, 4, 8 triplet eliminates 3, 4, and 8 in the rest of the box. This can't be 3. We now have a 1, 2, 9 triplet in this box, which eliminates 1, 2, 9 in the rest of the box. And this can't be 8 because of the 8 in the column. So this can't be 9. This must be a 7. The 7 eliminates 7 here, so this is 9, which eliminates 9 on the Renban. This has to be 8 then, which forces this to be 7, which forces this to be 9, which makes this 8, which makes this 9. This 8 eliminates 8 here, so this is 4, which makes this a 3. Therefore, this is 8. This 9 eliminates 9 here, so that's 2, which makes this 1, which makes that 9. 1 eliminates 1 here, so that's 2. This can't be 2 or 9, so it's 1. This can't be 1 or 9, so it's 3. This 4 eliminates 4 here, so this is 5, 6, 7, 8, 9 as a Renban. And we're just doing normal Sudoku now. 1 in column 3 has to be here. We have 8 ones. The last one, we know where it has to be. It has to be here. We should have 8 2s. We do. We know where the last 2 has to be. It has to be here. 3s, we have 8 3s. We know where the last 3 has to be. It has to be here. 4s. In this upper left hand, actually in column 1, where is the 4? It has to be here. We now have 8 4s. We know where the last 4 has to be. It has to be here. We have 8 5s. The last 5 has to be here. We have 9 6s, so that's good. We have 8 7s. The last 7's here. And then 8s. We have 8 8s, so this must be an 8. And that's the solution. Yeah, I mean, fairly... Yeah, just basically just, you know, you just restrict things enough And that's why I like going through thermometers a lot, especially long thermometers, because that usually does a pretty good job of restricting things. And then you can go from there. And we did. We also had the cages restricted, which was 1, 2, and 4, but that came from the thermometer, 2 for the restrictions. So, yeah. And that's the reason why I like going through long thermometers, because that restricts things a lot, which is helpful in solving these Sudokus, right? The goal for these is to restrict, obviously, to one digit. So that's what you're essentially trying to find. But if you can restrict it to 2 digits or less, or so obviously less is 1, but if you could get like 2 or 3 digits, that helps a lot, right? Which long thermos will normally do. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.